Previously, we learned how to multiply monomials by keeping the base, adding the exponent, and then we learned about power of a power and product of a power. Today's lesson is on dividing monomials, so we're almost going to do the opposite of what we were doing before. The first rule you need to know is the quotient of powers. If I had an example like x to the third over x squared, and we expanded it out, we'd have x times x times x over x times x. Every time I have the same variable on the top in the numerator and on the bottom in the denominator, they cancel out. So I was able to cancel this out twice, and I had one x left over. Therefore, x to the third divided by x squared equals x. However, if you notice, the exponents, 3 and 2, 3 minus 2 equals 1, and this has a power of 1. So our rule for the quotient of powers is a to the m divided by a to the n is going to equal a, so keep the base. Notice that they have to have the same base. Keep the base and subtract the exponents. Taking a look at an example, we have x to the fifth divided by x squared. Well, they have the same base, and I'm dividing, so I can keep the base, subtract the exponents. So my final answer is x to the 5 minus 2 power, which is x to the third. Now, with this second example, I have 2 times x to the fourth divided by x squared. If there's no number in front of the variable, remember, the number 1 is implied. So, the best way to solve these is to keep the numbers together and keep all common variables together. And then simplify. Well, 2 divided by 1, remember, we are not subtracting, we are dividing. Dividing, this is our most common mistake. We're dividing our numbers. We're technically dividing our powers too, but the way to divide powers is by subtraction of the exponents. So 2 divided by 1 is 2, and x to the fourth divided by x squared, well, that's 4 minus 2, so keep the base, subtract the exponents. I have 2x squared. I want you to pause the video and try this one on your own. Again, remember, put your common variables together, so your x's together, your y's together. All right, let's look and see if you did it right. I'm going to take x to the fifth divided by x, and I'm going to take y to the eighth divided by y cubed. Well, I have the same base here and the same base here, so I can keep the base and subtract the exponents. Well, if there's no number there, the number 1 is implied, so 5 minus 1 is 4. For the y's, I'm going to keep the base, subtract the exponents. 8 minus 3 is 5. And so my final answer is x to the fourth times y to the fifth. The other rule we're going to study is the power of a quotient. This is important because it's just like the power of a product, but now we have division. So if I have some numbers or variables, a and b, a divided by b, and I put that to the nth power. Just like in our previous video, we're going to distribute our exponent of m to each term, except now it's going to be, we're distributing it to the numerator and to the denominator. And so our final answer is going to be a to the m divided by b to the m. Taking a look at an example, we have x divided by y to the third. Well, I'm going to distribute my power of 3 to both terms, and I have x cubed divided by y cubed. Since I can't simplify it any further, we're done. Now, this example here, there's 2 things that we could have done. We could have either distributed the power of 4 to each term and then simplified, or notice that we have p squared divided by p. We could simplify first, and I'll show you both ways and show you that you get the same answer. We could have distributed, or let's simplify first. p squared divided by p, 2 to the power of 1, 2 minus 1 is 1. So I'm going to have 2p divided by 3 to the 4th power. Then I take this power of 4, distribute it to everything, and we have 2 to the 4th times p to the 4th over 3 to the 4th. Well, 2 to the 4th is 16, p to the 4th, and then we have divided by 3 to the 4th, which is 81. However, we could have distributed our power of 4 first to every term on the inside and gotten 2 to the 4th, p squared to the 4th. That's p squared to the 4th, which is p squared times p squared times p squared times p squared. We can multiply our powers here, 2 to the 4th, and that's going to give us p to the 8th. And then on the bottom, on the denominator, I have 3 to the 4th, and I have p to the 4th. Well, 2 to the 4th is 16, p to the 8th, divided by 3 to the 4th, which is 81, p to the 4th. But if you left this as your final answer, you'd get it wrong because you're not simplified here. So remember, when dividing, we keep the base, subtract the exponents, and 8 minus 4 is 4. So we get 16 p to the 4th divided by 81. And as you hopefully notice, these are the same answers. Therefore, it doesn't matter which route you take. They'll both get you to the right answer in the end. Let's look at one more example. I want you to try this on your own. Pause the video, attempt it, and then come back. All right, looking at this, we see there's no common variable. These numbers can't divide, so we cannot simplify on the inside in any way. So we're just going to take our power of 2 and distribute it to every term on the inside. So this is going to leave us with 4 to the 2nd times c to the 3rd to the 2nd times d squared to the 2nd all over 5 squared times e to the 4th to the 2nd times f to the 7th to the 2nd. Well, if we simplify this answer, we have 4 squared, which is 16, c to the 3rd to the 2nd, we're going to keep the base, multiply the exponents, 3 times 2 is 6, and then we have d, 2 times 2 is 4, so d to the 4th, all over 5 squared, which is 25, e to the 4th to the 2nd, 4 times 2 is 8, so e to the 8th, and f to the 7th to the 2nd, which is f to the 14th. And this is our final answer.